Page 294, lesson 5.1 is on rate of change and slope. So we've talked about this before. So rate of change, it says, is a relationship between two changing quantities. And rate of change, they said it's the change in the dependent variable over the change in the independent variable. We talked about it last year like this. And what that means, the little triangles, means a change. So this is change in y over change in x. Okay, looking at how our y values change divided by how our x values change. So if you look at problem 1, table shows the distance of a band marches over time. Is the rate of change in distance with respect to time constant? And what does the rate of change represent? So this one, they gave us a table. And what we can do then is look at points on the table. You could think of these as ordered pairs, like 1, 260, 2, 520, and so on. And then we're just looking at how do our y values change compared to how our x values change. So I know you guys know what the x and y are. You might want to label them just to make sure you don't get those mixed up. That's a common mistake people make, mixing up the y's and x's. So if we're doing change in y over change in x, just like the book did, I'm just going to do it here just because that's where my information's written down. But change in y, if you find the change in something, you're going to subtract the numbers. So change in y, we can either do 260 minus 520, or we can do 520 minus 260. So most people probably would prefer to do 520 minus 260. That'll give us a positive answer. Might be a little easier to work with. The deal is, when we start that out, when we do our change in y, however we do the change in y, we have to do the same order for this change in x. So if I started with 520 for the y, I'm locked in and I have to start from the x from that same coordinate. So in other words, I did 520 minus 260. Now I don't have a choice. I have to start with this x value. So I have to do 2 minus 1, which is fine because that's easier anyway. But sometimes, you know, it may have to just get a negative. It's just how it works. So anyway, you subtract just like the book showed there, and you get 260 over 1, which is the same as 260. And they did that for several points just to show you that it was the same for all of them. They did 3 different ones, and they got 260 over 1 for all of them. It's change in y over change in x. So if you look at our units here, this is like our x and this was our y. So change in y is in feet, x is in minutes. So when we do that, y divided by x, it's going to be feet per minute. Y divided by x, feet per minute. So that's 260 feet per minute. So we could say, you know, that the band is marching 260 feet every 1 minute. And the guide just says you get the same rate of change if you use non-consecutive rows. So in other words, if we would use, let's say we used 1 260 and 4 1040, you could work that out, and what'll happen is you'll end up getting the same answer. Okay, so it doesn't matter with slope. If it's a straight line, you can pick any 2 points on the line and you should get the same slope. So that's a good way too of checking your answer. If you have time, you could do 2 points and then work it out, and then if you have time, pick 2 other points and just double check and make sure you have the right answer. So the graph of a point from problem 1, these points are graphed on this line, and if you'll notice, this is linear. And the book this time's a little bit better. This one, I'm not a fan again of how they're starting out with this. If we're doing change in y and then change in x, we should do the y first and then the x, not the x and then the y. Anyway, this rate of change is called the slope. So a vertical change over horizontal change, or rise over run, or like I said, change in y over change in x. I like change in y over change in x better than rise over run, because sometimes we'll talk about, like if you look at this one on problem 2. On problem 2, it went down. Well, if it goes down, to me that's not a rise, that's a fall. Okay, so instead of looking at calling it rise or fall over run, I'd rather just call it change in y over change in x, because the change could be positive or negative. When we do these problems, our slope, depending what our slope is, our graph's going to look different. So a positive slope, our line would go this way. Negative slope, line would go this way. If our slope is 0, we're just going to get a horizontal line. And one more option is if we have an undefined slope. Undefined slope would be a vertical line. So we talked about the positive and negative slopes last year. Did this in 7th grade. So one way to help you remember this, a negative slope. Remember, we can make that into an N for negative. Positive slope, maybe creatively could make that into a P. I don't think I came up with that one. And then I think maybe new to you guys this year would be the 0 slope and the undefined slope. And we'll talk about those more as we go along here. So if you look at problem 2, they're asking what is the slope of the line. So finding the slope, you can pick any 2 points on the line. Pick something that's a nice point though, okay? Don't look at this and say, oh, I think this point right here is like, -3, -1.5. Well, if it's in between, I'd rather not pick that point. I'm going to pick something that hits right on the corner of these squares. Okay, so that's where they did the -2, -1, and 1, 1 as their points. And if these are graphed, or if you graph them, you could actually, depending on the numbers, if the numbers aren't real big, you could just count squares. You could say rise over run, or change in y over change in x. How do I get from one point to another point? Well, from the one point to the other point, I like to start with the point on the left. So from this point, we could say I'm going to go up 2, and I'm going to go over 3 to get to another point on the line. So change in y was 2 because I went up 2. Change in x was 3 because I went over 3. So my slope is 2/3. For sure, just by the direction of the line, we should know that this is going to be a positive slope. And you guys will learn as you go, what kind of slope, what kind of numbers you might be expecting. Basically, if you ignore the sign, if it's a smaller number, like if it's a fraction less than 1, it's going to be more flat. If it's a bigger number, like let's say the slope is 5, it's going to be more vertical, which kind of hopefully makes sense because this would have a bigger change in y and a smaller change in x, up 5 over 1, where let's say this slope was 1/4. 1/4, we just go up 1 and over 4. Okay, so that's another thing you can kind of get a feel for as you do these problems. Part B, looking at it, it's a negative slope. And then we could, on this one again, if it's graphed, we could just count squares. So we could say we go down 4 units, Down 4 is a negative 4, and then to the right 5 units is over 5. So negative 4 over 5. I'm not a big fan of where they put that negative sign, because if we're sloppy at all, that negative sign is going to blur into our fraction bar. So I would put the negative up with the numerator. The other thing you can do besides graphing it, which we might have to do sometimes depending if the numbers aren't very good, if the numbers are really big or something, is we might have to work it out by hand like we did earlier. So looking at this one, we have an option 2 minus negative 2 or negative 2 minus 2. Okay, you can go either way. I'm just going to do it this way, 2 minus negative 2. Now, if we do it that way, I started with this 2y value. I have to start with the negative 3x value. So that would be negative 3 minus 2. And then you can add the opposite here. And if you want, you can add the opposite here. And then that would be 4 over negative 5. You might say, well, they got negative 4/5. Well, if the negative's in a different part of the fraction, you can just move it to the other part. That's the same as negative 4/5. If you did it the other way, if you started negative 2 minus 2, you would have done 2 minus negative 3, and then you would have gotten negative 4 over 5. So it doesn't matter the order as long as you're consistent. However you start with on the y's, you have to start with the same point on your x's. So if we look at the got it, we're going to try and figure out what these slopes are. Got it, number 2. So looking at this, looks like it's going to be a positive slope. Find some points. They've got them kind of marked for you here. They didn't have to do that, but that was nice of them. So this looks like a point there, negative 3, 1. Another point would be 2, 3. And then, like I said, in this case, the numbers aren't too bad. If you wanted to count squares, you can. Otherwise, you can work it out by hand. It doesn't matter. Just understand, like I said, sometimes you will have to work these out by hand, depending on the numbers. So we can just label these real quick so we make sure we don't mess up our order. Again, changing y, we're going to subtract our y's, so we can either do 1 minus 3 or we can do 3 minus 1. 3 minus 1 would probably be a preference of most. So for our x's then, we have to keep the same order. We'd have to do 2 minus negative 3. So if you do this, 3 minus 1 is 2. 2 minus negative 3, you might want to add the opposite or change the sign, add a line, and that would be 5. So our slope would be 2/5. Another option you have on this one, since the numbers aren't too bad, we could just look at our graph. Since they're going by ones here, you could say I'm going to go up 2 and over 5, and my slope is 2 over 5, 2/5. Look at part B. So looking at this line, looks like we're going to have a negative slope this time. And we need to find a couple points. So 1 point on the line here, over here, this would be at negative 3, 2. Halfway between negative 2 and negative 4 would be the negative 3. And then another point they've got marked for us here would be 3, 0. So if we work this out, if you want to work it out by hand, keep track of your x's and your y's. So for the y's, changing y, we could do 2 minus 0. So that's starting with that y value. So we're locked in now. We have to do negative 3 minus 3. We have to start with the x value from the same point we started with the y value. So if we do that, 2 minus 0 is 2. Denominator, if you want to add the opposite there, you can. Would be negative 6. Like I said earlier, you can just put the negative in the numerator, so that would be the same as negative 2, 6. And then just notice in this one, we can reduce that by 2, so it reduces down to negative 1/3. So negative 1/3 is our slope. If you were looking at this from the graph, using the points that we had, you could say I'm going to go down 2, so that's a negative 2 since we went down. And that would be going over 6. So negative 2 over 6, and then reduces to negative 1/3. Anytime if you can reduce, what that means is there was another point in between there that would have been a nice point also. So instead of going down 2 and over 6, we could have gone down 1 and over 3 and got to a point on the graph. So top of page 296 just mentions here we can use any 2 points on a line to find the slope. Again, the book uses this as their slope formula. Some people get confused by that, so that's why I just go with this, change in y over change in x. That's what they're doing. They're subtracting their y's, they're subtracting the x's. These are subscripts, not exponents, because they're down lower, exponents are up higher. And then this just says x2 minus x1 cannot equal 0. Basically, we can't divide by 0, so we don't want our denominator to be 0, which we'll find out later sometimes has to be the case. So if you look at problem 3, what's the slope of the line through these 2 points? This one they worked out by hand. Basically the same as what we've been doing. And again, if you wanted to, these points aren't too bad. That if you wanted to just use graph paper, put them on your graph paper and then count your squares, you could do that also. It's not a bad idea if you have time to actually graph them, just so you can look to even see if it should be a positive or negative slope. Because if I just look at those points, I don't have that idea in my mind of, oh, it should be a positive slope, or oh, it should be a negative slope. If I graph those points, then I'm going to know, okay, it's going to be a negative slope on this problem. So we could do the same thing with the got it number 3 there. So if you look at problem 4, we got some special cases here. So problem 4, part A, they're asking for the slope of that line. If you look at this one, if you do the change in y's, your option is either 2 minus 2 or 2 minus 2. Well, it's going to be the same either way. So I guess I'll start with this one, like the book did. And then the x's, they did 2 minus negative 3. And what happens is we end up getting 0 divided by 5. 0 divided by 5 is 0. Like if I have $0 and I split it between 5 people, everybody gets nothing, okay? Slope is 0. So anytime if you have a horizontal line, the slope is 0. If you forget that, you can work it out. Change in y over change in x. Part B, we've got a vertical line. So what happens on a vertical line? Well, similar but opposite. They did 1 minus negative 2. So they started with this one. And then they did negative 2 minus negative 2. If you work that out, you can add the opposite here. So that would be 3 over 0. We can't divide by 0. I can't say, like, I'm going to take $3 and split it into 0 piles. We can't divide by 0, so that's called undefined. Sometimes when we're doing these, people kind of forget about which one it is, whether it ends up being 0 or whether it ends up being undefined. If you work it out, if you get 0 divided by a number, that's going to be 0. Okay, that's the number symbol before hashtag was a thing. If you have a number divided by 0, that's my version of a unicycle. And just like a unicycle starts with a U, so does undefined. And we've talked about before, math people like to have shortcuts on things and not write things out sometimes. You can actually just write the letter U means undefined, because it takes so long to write undefined. You can actually just put a U, okay? So if it looks like a unicycle, U, undefined. If it doesn't look like a unicycle, then slope is 0. So if you look at the got it number 4, they're asking for the slope between these points. So just like we've done before, we can do change in y over change in x. If you'd like to, you could graph these. From the graph, you might be able to just tell what's going on there. So change in y's, if you want, you can do 2 minus -3. Then for the x's, we have to start here, which is 4 minus 4. This one actually 4 minus 4, if you did it backwards, I wouldn't know any different. It'd still be 4 minus 4. In the numerator here, you can add the opposite then. So this would end up being as 5 divided by 0. That's our unicycle problem, so this is undefined. So then similar idea if we look at part B. So change in y, -3 minus -3. I'm going to start with this one just because I see what's coming on the y, on the x's. So x is 5 minus -1. In both cases, if you want to add the opposites on those, you can. So this time we get 0 divided by 6. And if you take 0 and you divide it into 6 piles, each pile has 0. So this concept summary, just again, putting all this together, what we talked about earlier. Positive slope, negative slope. And like I said, if you remember, positive, negative. 0 slope is horizontal, and undefined slope. So we look at the lesson check number 1. Is the rate of change in costs constant with respect to the number of pencils bought, and explain? So what they're asking basically is, whether it's a constant change here. We could divide a bunch of these out if you wanted to, or you could kind of look at what's happening, what kind of changes we have in our table. So here you could see this cost went up 75 cents for 3 more pencils. The cost went up 75 cents for 3 more pencils. And this one, the cost went up $1.25 for 5 more pencils. Well, if you look at the first one, 75 cents for 3 pencils, that's 25 cents per pencil. $1.25 divided by 5, that would also be 25 cents per pencil. So that would be constant. The other option you have, which is going to take more time, would be you could take these points and you could say, what's the slope between those 2 points? And then you could take your third point, take your second and third points, what's the slope between those 2 points? And then take your third and fourth point and say, what's the slope between those 2 points? Okay, again, I think we could probably get by with what we just did in the table there, if that makes sense. If we look at number 2, they're asking what the slope of this line is. So this one from the graph, we could say down 1 and over 5. And so our slope would be -1/5. You could otherwise work it out by hand, would work also. So this gives you an idea of how to work with rate of change and slope.